Everybody. In this video, we're going to continue to talk about objects. And because Java is an object-oriented language, there is a lot to say about them. Now, we've already been interacting with classes in programs. For example, we've used the random class and the math class, and these things are just objects that somebody built for Java and that are accessible to you either just in the standard Java, or maybe you have to use some sort of import statement to get them to work. Right? So we already kind of know how to interact with these classes and with these objects, and the thing that's kind of happening new now is how we are going to interact with the objects that we create. For example, perhaps when you create an object, you want to store them in arrays. So we've talked about having string arrays, and it turns out that an array can hold objects as well. So here I have an example of some object called student, and then I use student brackets, and then say new student 40, which creates a roster of 40 students. And then I could perhaps go through a for loop and just set roster at I is equal to new student, and maybe set it equal to a name or whatever kinds of attributes student has. Another way that objects can interact with each other is with composition and aggregation. An object can actually contain another object, and the relationship between the two is called an association. The specific ones I have here are composition and aggregation. So composition represents ownership of another object. For example, a deck can contain cards. Meanwhile, aggregation represents has a relationship with an object. A player, for example, has cards drawn from the deck. So here we have a card object, a deck object, and a player object. And we can actually draw diagrams to represent these kinds of relationships. So here I have this deck, and composition, which happens to be represented with this filled in diamond. So this shows that deck is a composition of cards. And then here I have aggregation, which is perhaps saying one player has up to 5 cards. And so here I have a clear diamond to indicate that a player aggregates cards. So again, to represent aggregation in these kinds of diagrams, which are called UML, the filled diagram denotes composition, and an empty or clear diamond denotes aggregation. So let's look at an example of deck class. As before, we need to name the class the same thing as the file name, and now we are going to have an array of cards. So as I mentioned earlier, you can have an array of objects. In this case, it's going to be card objects, and so I have an array of card objects. And then I'm going to create this constructor. Now, with an ordinary playing card deck, it's 52 cards, and the cards have suits of clubs, diamonds, hearts, and spades, and ranks from 2 through 14, where 11, 12, 13, and 14 are Jack, Queen, King, and Ace. And now what I'm going to do is I'm actually going to build this deck object inside my constructor. Well, I'm going to construct the deck object. So I have a for loop that says for each suit in suits and for each rank in ranks, I'm going to set cards at I to be equal to new card, rank, and suit, I++. And so here I have a for each loop that's actually going to set each of the card values based on the standard playing card deck. All right, so here I am showing how you can use a constructor that has an array, and the deck itself is taking up all these card objects. Well, now that we have this new object, which is called deck, let's talk again about getters and setters. We talked about getters before when we were talking just about the card object. We have get suit and get rank, so we could return that. And now we have this concept of setting values. For example, it might make sense to have inside your deck object this ability to set the cards to an already created array of card objects. And it would literally be this.cards is equal to cards. Another one that we might have is set card, which takes in an index and some card object and sets the deck at that index to be equal to that card. And so this is the idea of mutating or setting the deck object, in changing its state, basically. So methods can be accessors or mutators. In other words, getters and setters. Methods with get, so normally you write it get something, produce some value, and methods with starting with set usually perform some action. And so here's just some vocabulary. It's just that accessors are getters and mutators are setters. You can call them either way. Now I'd like to introduce the concept of static variables. So far, we've talked about instance variables, which means that each instance of the class has its own copy of the variable. So for example, in the card class, each card object had its own suit and rank variables. And in the deck class, each deck object has its own cards array variable. In contrast, static variable means that it's shared across all instances of an object. Instead of using this.variable, we use className.variable. And we've seen this before with math class. In math class, everything is static. Good. So for example, math.py is a public static variable inside math class that is shared by everyone. This is in contrast to this.rank, which is a class variable that's unique to each card. So when we look at our deck class and we say, here's this array of cards, I've set up these variables called char array of suits and int array of ranks. And if I'm assuming that I have a standard 52 card deck, I might as well make these static and accessible by every instance. Just in case I'm using a 52 card deck, I don't have to, but seems useful. A couple of things to point out. If a variable is declared as final in Java, its value will not change once it has been initialized. And so the final keyword in Java is used to indicate that a variable's value should remain constant throughout. So if you did want to maybe later on change the suits or ranks, you couldn't use the final keyword. So going back to what I had before, which just has char suits and int ranks with those are both arrays. Let's say, for example, I wanted to add a new suit, maybe one called Moon. Well, if I have private static char array suits C, D, H, and I have M, S, I can go ahead and do that because I do not have the final keyword here. But this can cause unusual behavior later on because it means the values can be changed at any point in the program's execution. And that might lead to unexpected behavior if you don't manage very carefully the behavior. A few more things that we should know about objects is the fact that there is a class called object, capital O, and it is the root of the class hierarchy, meaning that every class has object as a superclass, and all objects, including arrays, implement methods of this class. And we've talked about a couple of these methods already. So we know equals, and normally what equals does, if it's not otherwise implemented, is it's going to see if the memory address of two objects is the same, right? So when we talk about strings, we always do dot equal, the word equals, and not the symbols of equals equals. We briefly saw get class and hash code
because when we do get to string, the natural way to do it that object has is get class.getName with an @ sign and then integer.toHex string. That's not normally what we want with the toString method, so we'll often override it. So even though a lot of these get overridden, it is important to know that object has already some way of implementing it, so it has a standard way that it works. It's just you have to write your own method when you want your object to do something that's more normal for it to do based on what it is. And the last little keyword I'm going to talk about is instance of. So instance of tells you whether objects are a certain type of object. Meaning, let's say that we have something called a shape, and well, a rectangle is a shape. So if you said, okay, a shape is an instance of rectangle, then you would return the area of the rectangle. Otherwise, if the shape is an instance of a circle, then you return the circle. So here, rectangle is a particular object and circle is a particular object. And so you can literally just check to see if a particular instance is an instance of a particular class. All right. The thing I want to leave you with, as I did on the previous objects video, is that there's quite some vocabulary to imprint into your minds to make sure that you can talk about objects in a good way. So that includes things like final, static, instance variable, superclass, instance of, getter and setter methods, and composition and aggregation. And so those were some of the important vocabulary words that appeared throughout this video. And of course, we had the vocabulary words that appeared in the previous video. And so these are going to be important to be able to speak about what you're doing with objects. In the next video, we'll continue talking about objects and how to diagram them, which I've already sort of started hinting at, but we'll go into more depth. Other than that, that's all I have for you right now, so thanks for watching.